1943, the industrial heart of the United States pulsed with the relentless urgency of World War II. The nation, mobilized on an unprecedented scale, was transforming its factories into gigantic arsenals, and no place symbolized this metamorphosis more than the Willow Run complex in Michigan. There, the Ford Motor Company, an automotive industry titan, had converted its production lines for a monumental task, the mass manufacturing of the B-24 Liberator bomber. These aircraft, true flying fortresses, were the backbone of Allied air campaigns, crucial for tipping the balance on both the European and Pacific fronts. The atmosphere inside the factory was a deafening industrial symphony. The incessant hammering of rivets, the sharp hum of pneumatic tools, the creaking of cranes moving gigantic fuselage sections. It was a labyrinth of steel beams, heavy machinery, and thousands of workers, all driven by a singular purpose: victory. Every molded aluminum piece, every connected electrical wire, every fixed rivet represented a step forward in the fight against the Axis powers. The pressure was immense, the demand for aircraft insatiable. However, behind this facade of frantic productivity and unwavering determination lay a less visible but equally critical battle: the struggle against the inertia of established methods and the waste inherent in unoptimized processes. This would not be a battle fought by decorated generals or renowned engineers, but by an unlikely figure, a factory worker of just 28 years, Dorothy Henderson. Her audacity in questioning an assembly process that had been considered unquestionable for months, an industrial dogma, was about to unleash a silent but profound revolution in mass production methods. The story of how a single keen observation could redefine efficiency in wartime is a testament to the power of the human mind in the face of adversity. Dorothy Henderson did not possess the academic credentials of an engineer, nor the decades of experience of a factory manager. Before the global conflict, her life was dedicated to the art of tailoring in Detroit, a craft that demanded meticulous precision and a keen eye for detail. She spent her days harmonizing fabrics, cutting patterns, and sewing garments, developing an intrinsic understanding of sequential logic and spatial optimization. Every scissor cut, every needle stitch was a deliberate act, aiming for maximum efficiency and minimum material waste. In 1942, the patriotic call for industrial labor resonated throughout the country, and Henderson, like millions of other American women, answered the call. She traded the delicacy of the needle for the robustness of the riveter, the soft touch of fabric for the harshness of metal. The transition was more than a job change, it was a brutal metamorphosis. Her hands, once skilled with silk and linen, now adapted to the weight and vibration of pneumatic tools, the intense heat of welds, and the pungent smell of oil and metal. This physical and mental adaptation was a demand imposed by the war machine, a personal sacrifice for a greater goal. The Willow Run factory, with its overwhelming scale, became her new home, an environment where the precision of her former profession would find a new and unexpected purpose. In her first months at Willow Run, Dorothy Henderson immersed herself in the complexity of B-24 assembly, absorbing every detail of the process. The factory operated in exhausting 12-hour shifts, 7 days a week, under the relentless pressure to maximize production. Every day, hundreds of workers toiled at a frantic pace, transforming piles of metal parts into bombers ready for combat. What intrigued her most, however, was not the technical sophistication of the aircraft itself, but the seemingly excessive number of repetitive and, in her view, unnecessary movements that each worker was forced to perform. She observed the mechanical dance of the workers, a ballet of effort that seemed more choreographed by tradition and habit than by a genuine pursuit of maximum efficiency. It was a subtle but persistent dissonance between the relentless pace imposed by the war machine and the actual, often inefficient cadence of human labor. This initial observation, almost a premonition, would plant the seed of an idea that would challenge the conventional wisdom of mass production. Every day she saw lost opportunities, time slipping through the workers' fingers, and valuable energy being dissipated in tasks that could be simplified. The assembly process for the B-24 Liberators center section, a crucial piece that formed the aircraft's backbone and weighed approximately 800 pounds, was a glaring example of this inefficiency. Teams of 4 workers were tasked with manually transporting these heavy sections along an assembly line, stretching over 200 yards. Henderson noticed that, due to the illogical configuration of the workstations, parts were frequently repositioned multiple times before being permanently fixed. Each repositioning was no trivial adjustment. It was an expenditure of 8 to 12 minutes of arduous work and precious time. Multiplied by hundreds of bombers produced weekly, these small delays accumulated into monumental losses of work hours, which translated into days and weeks of delayed production. Henderson's vision, trained in optimizing every movement and tailoring, saw a fundamental flaw in this process. She perceived that brute force was being used to compensate for a design flaw in the workflow, an approach that, although common, was unsustainable under the pressure of war. Each time a team sweated to move a section, she saw not only the physical effort, but the vital time that could be dedicated to building more aircraft. Henderson's epiphany did not come from a sudden moment of inspiration, but from persistent and methodical observation. It occurred during a lunch break, a moment of respite in the factory's chaos. While workers rested, she observed the pneumatic tools, symbols of power and speed, lying idle for long periods. These machines, designed to accelerate production, waited while workers struggled to manually move parts between stations. It was a paradoxical image, advanced technology awaiting human brute force, a stark disconnect between potential and reality. This contrast sharpened her intuition. Determined to quantify what her eyes already perceived, she began secretly timing different aspects of the process, using a small wristwatch, a graduation gift that held sentimental value. For 3 weeks, she compiled meticulous data, recording the times of each movement, forced pauses, and moments of inactivity. What she revealed was a disturbing pattern of inefficiency that, surprisingly, no one had questioned before, accepted as an inevitable part of the process. Her analysis would transform intuition into irrefutable evidence. The numbers collected by Henderson, recorded in discrete notebooks, confirmed her hypothesis with undeniable clarity. The layout of the workstations forced a counterproductive flow, a true antithesis of efficiency. Instead of a linear and logical progression, parts moved in a zigzag pattern, wasting not only valuable factory floor space but also precious time. Furthermore, she documented how multiple teams frequently competed for the same restricted space, creating bottlenecks that paralyzed the assembly line at critical moments. Her experience as a seamstress, where every unnecessary movement meant loss of material and time, resonated deeply. She envisioned the assembly line as a vast sewing machine, where each component should smoothly slide to the next stage, without interruptions or deviations. In her sketches, made on scraps of paper during rare breaks, she redesigned the flow, seeking a harmony and logic that the factory, in its haste and under the pressure of war, had neglected. These rudimentary but insightful drawings would be the embryo of a radical transformation. The decision to present her observations to Frank Morrison, her direct supervisor, was not taken lightly. Henderson knew she was risking her position, perhaps even her reputation, by challenging an established system. However, the sense of patriotic duty and the undeniable urgency of the war outweighed any personal fear. She believed that the inefficiency she witnessed was an obstacle to victory, and her silence would be a failure. Morrison, a veteran of the automotive industry with 15 years of experience, was, like many of his generation, skeptical of new ideas coming from factory workers. He had seen many newcomers try to reinvent the wheel without understanding the complexities inherent in mass production. However, Dorothy's consistency and dedication during her months of hard work at the factory earned her an audience. Morrison agreed to listen to her, perhaps out of mere courtesy, not imagining that he was about to witness a proposal that would fundamentally challenge everything he thought he knew about industrial efficiency and optimization. The meeting would be an unexpected turning point, not only for Henderson, but for the factory itself. When Dorothy Henderson finally presented her detailed sketches and meticulous timings, Frank Morrison was genuinely surprised. The level of detail and the precision of her observations were undeniable, going far beyond what he expected from a line worker. She had not only identified the bottlenecks and waste points, but had quantified the lost time and idle moments of tools with impressive clarity. Even more impressively, Henderson had calculated that her proposed reorganization could reduce the assembly time for each center section of the bomber from 4 hours and 20 minutes to approximately 3 hours and 15 minutes. Morrison, a man of numbers and results, immediately understood the magnitude of this potential saving. If the calculations were correct, this time reduction would result in a significant increase in aircraft production, without the need to hire more workers or acquire new and expensive equipment. It was a revelation. The key to much greater efficiency lay not in the brute expansion of resources, but in the intelligent optimization of existing processes. The truth was there, documented on simple papers, but with immense transformative power. Despite Morrison's growing conviction, Henderson's proposal faced considerable resistance within Ford's hierarchical structure. Senior engineers with decades of experience and a natural attachment to established methods argued that the current process was the result of meticulous design and that hasty changes could compromise the quality and safety of the aircraft, endangering the lives of pilots. Supervisors from other shifts feared the complex logistics of retraining hundreds of workers in new procedures, anticipating temporary production delays that could be catastrophic in wartime. Even some of Henderson's colleagues expressed skepticism, concerned that greater efficiency could, paradoxically, lead to layoffs if fewer workers were needed for the same output. It was a classic clash between innovation and tradition, between the practical vision of a factory worker and the dogma established by years of industrial practice. The idea that a woman, without formal engineering training, could challenge the status quo was, for many, almost unthinkable. The battle for the acceptance of her idea would be as arduous as the war itself. However, the War Department's pressure to increase bomber production was relentless and outweighed any internal resistance. Losses on the front were heavy, and every additional aircraft meant a crucial tactical advantage. Colonel James Patterson, military liaison officer at the Willow Run factory, had direct orders from Washington to find solutions, no matter how unconventional. When Frank Morrison presented Henderson's proposal, Patterson, a visionary strategist, recognized the immediate potential. He saw beyond the humble origin of the idea, realizing that the war demanded flexibility, boldness, and above all, results. The colonel authorized a pilot test on a limited section of the production line, a decision that broke with traditional industry protocols, which usually favored innovations coming from engineers or high-ranking managers. It was a calculated risk, but the need to accelerate aircraft production outweighed bureaucratic caution. Dorothy Henderson's fate was sealed. Her destiny, and perhaps that of many soldiers, would depend on the success of this experiment. The pilot test of Henderson's methodology began on a cold Monday in October 1943. A team of 20 carefully selected volunteer workers operated on an isolated section of the assembly line, under Henderson's temporary supervision. The physical reorganization of the workstations, a Herculean effort, had been carried out by Henderson and the maintenance team over an entire weekend, with every piece of machinery and every workbench moved to its new optimized location. The first few days were, as expected, marked by confusion and frustration. Workers, accustomed to the old patterns of movement and positioning, struggled to adapt to the new cadence. Initial assembly times were, in fact, slower than the original process, fueling the skepticism of observers and the workers themselves. Henderson, however, stood firm, demonstrating calm and patient leadership. She explained each step clearly, adjusting details based on direct feedback from the workers and reiterating the vision of a more efficient process. She knew that adaptation required time and that the real test would come in the second week, when the pressure of real production would set in and the learning curve would begin to show its fruits. In the second week of the pilot test, a remarkable change began to manifest, dispelling initial skepticism. Dorothy Henderson's team not only met the projected times, but consistently exceeded them, demonstrating increasing proficiency in the new system. The B-24 bomber's center section, which previously took 4 hours and 20 minutes to assemble, was now completed in an average of 3 hours and 8 minutes, an impressive feat, 7 minutes faster than Henderson's own most optimistic projection. This achievement was an undeniable testament to the effectiveness of her methodology, proving that practical observation could overcome years of tradition. But the gains were not limited to speed. Assembly quality not only remained, but improved significantly, with a notable 40% reduction in defects requiring rework. This meant less material waste, less time spent on corrections, and crucially, more reliable aircraft. Henderson's efficiency was delivering tangible results, exceeding the most optimistic expectations and silencing critics. The benefits of Henderson's methodology extended beyond production numbers and quality. Workers involved in the pilot test reported a significant reduction in physical fatigue, a direct benefit of eliminating unnecessary movements and the more natural flow of the process. The frustration of waiting for tools or repositioning heavy parts had drastically decreased, resulting in a more harmonious and productive work environment. Frank Morrison, the supervisor who initially doubted, meticulously documented every aspect of the test, improved production times, elevated quality indices, a visible increase in team morale, and a reduction in operational costs. The numbers were irrefutable, presenting an undeniable case for the widespread adoption of the new method. Henderson's methodology had revolutionized production efficiency without compromising quality or safety, proving that practical observation and innovation could overcome ingrained tradition. It was a clear victory of applied intelligence over inertia, a milestone that would redefine industrial practices. When Colonel Patterson reviewed the results of the pilot test after the 2 crucial weeks, his decision was immediate and unequivocal. He authorized the expansion of the new process to the entire B-24 production line at Willow Run. This complete validation of a factory worker's observations and innovations represented a historic milestone, not only for the factory, but for the entire defense industry. It was concrete proof that the courage to question the status quo, combined with rigorous analysis and a practical vision, could generate monumental transformations. The Colonel's decision not only boosted Dorothy Henderson's career, elevating her from a factory worker to a figure of influence, but also sent a clear message to the entire American industry. Innovation could emerge from anywhere, and the urgency of the war demanded that all voices, regardless of their origin or position, be heard and valued. The era of rigid hierarchy and exclusive innovation by engineers was beginning to give way to a more inclusive and effective approach. The full implementation of Henderson's methodology across the entire Willow Run factory was a massive undertaking, requiring the meticulous coordination of over 8,000 workers spread across 3 daily shifts. The transition process was planned with surgical precision to minimize any disruption to production, with sections of the assembly line being gradually converted over a 6-week period. Dorothy Henderson was officially promoted to Production Efficiency Specialist, an unprecedented position created specifically for her. Recognizing her singular contribution, she assumed the vital responsibility of training supervisors and key workers in the new procedures, ensuring a smooth and effective transition. Her meteoric rise from line worker to recognized specialist in less than a year demonstrated how the war opened doors for unexpected talents, regardless of academic background or prior experience. It was a testament to the power of merit and adaptability in times of national crisis. During the demanding transition period, Dorothy Henderson worked exhausting 16-hour shifts, moving tirelessly across the entire factory floor. She was the embodiment of the new methodology, a constant presence on the factory floor, solving problems in real time, answering countless worker questions, and making fine adjustments to the process as needed. Her unwavering dedication and practical expertise, acquired through observation and direct experience, earned the respect of even the most skeptical engineers who had initially resisted her ideas. They recognized that Henderson's understanding of the practical challenges of production surpassed many academic theories. The success of the implementation solidified her position as one of the most respected figures in the factory and paved the way for future innovations based on the observations of line workers. It was a new era of collaboration, where the value of practical experience was finally recognized and integrated into the industrial management process. The results of the full implementation of Henderson's methodology exceeded all expectations, redefining mass production standards. In the first 3 months after the universal adoption of her principles, B-24 bomber production at Willow Run jumped from 8.5 to 12 3/10 aircraft per day, an impressive 45% increase. And most remarkably, this leap in productivity was achieved without the need to hire additional workers or acquire new expensive equipment. The total assembly time for each bomber was drastically reduced from 18 hours to 13 2/10 hours, representing a saving of 4 8/10 hours per aircraft. With the factory producing 350 bombers monthly, this translated into a saving of 1,680 man-hours per month at Willow Run alone. Annually, the saving exceeded 20,000 man-hours, a volume of work that could be redirected to other critical fronts of the war effort. The War Department, attentive to Willow Run's extraordinary results, quickly realized the potential to replicate Henderson's methodology on a national scale. Teams of specialists were sent to study her principles and adapt them for the production of tanks, artillery, and a wide range of other military equipment in various factories across the country. The cumulative impact of these applications in dozens of defense facilities resulted in estimated savings of over 15 million man-hours during the final 2 years of the war. This monumental figure was not just an abstract number. It represented a vast reservoir of human effort and resources that could be redirected to other critical fronts of the conflict, from ammunition manufacturing to troop training. It was a force multiplier, a silent strategic advantage that amplified American industrial capacity at a time of extreme need, contributing directly to the acceleration of the war's end. The innovation of a single factory worker was, in fact, reshaping the war-making capability of an entire nation. Dorothy Henderson's work gained recognition that transcended the physical confines of the Willow Run factory, reaching the highest echelons of the American government. In January 1944, she received an invitation to Washington, D.C., where she would present her methodology to a joint committee of the War Department and the Navy. Before an audience composed of decorated generals, high-ranking admirals, and influential civilian officials, a factory worker was recognized as a national expert in industrial efficiency, a historic moment that challenged the social and hierarchical conventions of the time. Henderson did not merely describe the technical aspects of her reorganization. She emphasized the fundamental importance of valuing the observations of line workers, whose practical insights were often invaluable and, frequently, ignored. Her voice, once confined to the factory's noise, now echoed in the halls of power, advocating for a new approach to industrial management that recognized the intrinsic value of shop floor experience. Henderson's presentation in Washington, D.C., had a transformative result: the creation of the Workers' Innovation Program, an unprecedented national initiative. This program encouraged workers in all defense factories to propose improvements to their own production processes, democratizing innovation. During 1944 and 1945, the program generated over 12,000 suggestions, of which approximately 3,200 were successfully implemented, resulting in additional savings and productivity increases. Dorothy Henderson was appointed chief consultant for the program, traveling tirelessly across the country to evaluate proposals and assist in implementing the most promising ones. She became a living symbol of the belief that the practical intelligence of the workforce was an untapped national resource, capable of propelling the nation towards victory. Her journey inspired thousands of workers to look at their own workplaces with a new critical and proactive eye. Henderson's methodology not only optimized processes but also had a profound impact on morale and work culture nationwide. Workers who once felt like anonymous cogs in a vast industrial machine now saw themselves as valuable and recognized contributors to the war effort. The recognition that their ideas could make a tangible difference in production created a renewed sense of purpose and engagement, transforming attitudes towards work. Supervisors and managers were trained to actively encourage worker feedback and to implement viable improvements, fostering an environment of collaboration and continuous innovation. This cultural shift represented a fundamental transformation in American industrial relations, setting precedents that would influence management practices for decades. The voice of the common worker, once often silenced, gained new weight and respect, proving that collective intelligence was an invaluable asset. Dorothy Henderson often emphasized that her discovery was not the result of isolated individual genius, but rather of careful observation and a willingness to question established practices that many accepted without thought. She encouraged other workers to adopt a similar mindset, arguing that small improvements implemented by many people could have enormous collective impacts, like a river formed by countless tributaries. Her lectures in factories across the country inspired thousands of workers to critically examine their own work processes and to propose innovations, however small. It was a democratization of creativity, a recognition that practical wisdom was an abundant resource just waiting to be valued and applied. Henderson became an evangelist for the idea that innovation was not a privilege of a few, but an inherent capacity in everyone, especially those closest to the real work and its daily challenges. The strategic impact of Henderson's innovations extended directly to military theaters of operation, influencing the course of the war. The accelerated production of B-24 bombers allowed the Army Air Command to significantly expand its operations in both Europe and the Pacific during 1944. Squadrons that previously operated with chronic aircraft deficits could be re-equipped more quickly, increasing the frequency and intensity of strategic bombing missions. In the European theater, the additional availability of bombers intensified the campaign preceding D-Day, degrading German defenses and transportation infrastructure, preparing the ground for the Allied invasion. Each extra bomber meant more firepower and greater force projection capability, altering the tactical and strategic balance in favor of the Allies. The factory, far from the trenches, was forging victory. In the Pacific, the availability of additional bombers, a direct result of efficiency improvements, allowed for the expansion of operations against Japanese industrial targets and more effective support for amphibious operations on strategic islands. Field generals reported that the consistent availability of replacement aircraft allowed for more aggressive and sustained operational planning, reducing the gaps that previously limited their offensives. Colonel Patterson, the military liaison officer who had bet on Henderson, estimated that her innovations indirectly contributed to shortening the war by several weeks. This time, saving not only meant preserved material resources, but crucially, saved human lives, both military and civilian. It was irrefutable proof that efficiency on the factory floor had a direct and measurable impact on the front lines, a vital connection between industrial production and military success. Dorothy Henderson's influence extended far beyond the end of World War II, profoundly transforming civilian industrial practices. Automotive companies, which had converted their production lines to military equipment during the conflict, applied similar workflow optimization principles to their post-war civilian operations. The Ford Motor Company, owner of Willow Run, incorporated many of her methodologies into its automobile plants, driving the post-war economic boom and setting new productivity standards. Other industries, from appliance manufacturers to chemical companies, sent representatives to study her techniques and adapt them to their own processes. Universities began to include case studies based on her work in industrial engineering and business administration curricula, solidifying her academic legacy. The concept of continuous improvement, driven by observations from line workers, became a fundamental principle of modern industrial management, a lasting legacy of her vision. Henderson had demonstrated that innovation was not an exclusive privilege of research laboratories or engineering departments, but could emerge from anyone willing to observe carefully and question established practices. It was a lasting lesson about the ubiquity of creative potential, a reminder that the best ideas often come from where they are least expected. Her pragmatic, worker-focused approach redefined what it meant to be an efficiency expert. She proved that practical intelligence, combined with the courage to challenge the status quo, was a powerful force for change. This philosophy not only boosted productivity during the war, but also laid the groundwork for a new era of industrial management, where the voice of the worker would become an essential component in the pursuit of operational excellence. Henderson's legacy was living proof that innovation had no boundaries of gender, education, or social position. In the final months of the war, with Allied victory becoming a certainty, Dorothy Henderson faced a new and complex challenge, adapting her methodologies for the transition from military to civilian production. With the end of hostilities in sight, defense factories needed to quickly convert their production lines back to consumer products, a process known as reconversion. Henderson led planning teams that developed detailed protocols for this transition, applying the same workflow optimization principles that had revolutionized bomber production. Her experience and vision were invaluable in minimizing downtime during conversion and ensuring that the hard-won efficiency improvements were not lost in the shift. A nation's ability to adapt quickly from war to peace depended, in large part, on the effectiveness of these reconversion plans. She worked directly with automotive engineers to redesign civilian automobile production lines, incorporating valuable lessons learned from mass bomber manufacturing. The reconversion process, which many experts feared would take months or even years to complete, was accomplished in weeks, thanks to the methodologies developed by Henderson and her team. Her ability to visualize and optimize complex processes had become a transferable skill that transcended specific products or industries. It was proof that practical intelligence, once cultivated and applied, could be successfully used in any industrial challenge, from building warplanes to producing cars for the American family. The agility and efficiency demonstrated in reconversion were crucial for boosting the post-war economy and meeting pent-up demand for consumer goods. Dorothy Henderson's official recognition culminated in 1945 when she received the Presidential Medal of Freedom, the highest civilian honor in the United States, from President Harry Truman himself. The ceremony at the White House marked a historic and symbolic moment, where a factory worker was recognized at the highest level of government for her extraordinary contributions to the war effort. In her acceptance speech, Henderson, with her firm and clear voice, emphasized that her medal represented not only her individual work, but the value and importance of all American industrial workers who had contributed to the war effort. She used the platform to advocate for the continuation of programs that encouraged workplace innovation and recognized the invaluable contributions of line workers, solidifying her legacy as an advocate for the workforce. After the award ceremony, Dorothy Henderson was invited to join the newly formed National Council on Industrial Productivity, where she would continue to influence American industrial policies during the post-war era. Her remarkable trajectory, from a factory worker to a prestigious national advisor, demonstrated how the war had created unprecedented opportunities for social mobility and recognition based on merit and contribution, regardless of social origin or gender. It was a story of ascent, forged in the urgent necessity of war and the undeniable talent of a woman. Her presence on the council ensured that the shop floor perspective continued to be heard and valued in discussions about the future of American industry, a lasting testament to her influence and vision. In the years following the end of the war, Dorothy Henderson did not rest on the laurels of her recognition. She established a consulting firm specializing in industrial process optimization, becoming one of the first women to found an engineering consulting firm in the United States. Her company, Henderson Industrial Solutions, worked with hundreds of factories across the country, applying and refining the methodologies developed during the war. She trained a new generation of efficiency experts, many of whom were war veterans who had returned to civilian careers in industry, seeking to apply the lessons learned in the conflict for peacetime prosperity. Her entrepreneurial vision and her ability to translate practical experience into scalable solutions made her a prominent figure in the post-war industrial landscape. Henderson frequently hired former factory workers as consultants in her company, arguing with conviction that their practical experience was often more valuable and applicable than isolated theoretical academic training. Her pioneering company set new standards for the industrial consulting industry and influenced the development of management practices that would become fundamental to American industrial competitiveness in the following decades. Henderson continued to emphasize the importance of listening attentively to line workers and creating organizational cultures that encouraged innovation at all levels of the company. Her philosophy that the best ideas often come from the people closest to the real work became a widely accepted principle in modern industrial management, a legacy that endures to this day. The methodology developed by Dorothy Henderson during World War II established foundations that would continue to influence industrial practices for decades, transcending the original context. Her principles of workflow optimization, reduction of unnecessary movements, and valuing the practical knowledge of workers became central elements of what would later be globally known as lean manufacturing and continuous improvement. Japanese companies, for example, studying American industrial practices during post-war Reconstruction, incorporated many of Henderson's techniques into their own production systems, which would later influence global industry. Henderson's vision, born out of wartime necessity, became a pillar of modern industrial efficiency, demonstrating the universality of her principles. The transformation of a seamstress into one of America's most respected industrial efficiency experts demonstrated that innovation and leadership can emerge from anywhere when the right circumstances align with individual determination and opportunity. Henderson proved that questioning established practices, observing carefully, and proposing solutions based on practical experience can result in transformations that save not only time and resources, but also human lives. Her story remains a powerful testament to how determined individuals can make extraordinary differences when they have the courage to challenge the status quo and persist in the face of initial resistance. She personified the resilience and ingenuity of the American spirit in one of history's most challenging periods. Dorothy Henderson's story, though a composite narrative, resonates with the fundamental truth that victory in World War II was a multifaceted effort, where ingenuity on the factory floor was as crucial as bravery on the battlefield. Her revolutionary assembly methodology not only optimized B-24 bomber production but also catalyzed a paradigm shift in American industrial management. The saving of 15 million man-hours was not just an impressive statistic, it was a testament to the power of practical observation and the courage to challenge the established, a tangible contribution to accelerating the end of the conflict. This saving represented an invaluable strategic gain, freeing up resources and time for other battlefronts and saving countless lives. Henderson's legacy transcends the war period, influencing management philosophies that are now pillars of global industry, such as lean manufacturing and continuous improvement. Her journey, from a seamstress to a renowned industrial consultant and honored with the Presidential Medal of Freedom, serves as a powerful reminder that innovation has no boundaries of gender, education, or social position. Her philosophy of valuing the practical intelligence of line workers continues to inspire leaders to cultivate environments where creativity and efficiency can flourish at all levels, from the factory floor to corporate boardrooms. It is a timeless lesson about the value of untapped human potential. The transformation of the Willow Run factory under Henderson's influence is a microcosm of a broader cultural shift, where the voice of the common worker gained new weight and recognition. Dorothy Henderson's story is an invitation to reflection on the importance of questioning, observing, and believing in the transformative potential of ideas that emerge from the most unexpected places. She reminds us that the greatest revolutions often begin with a simple act of courage and a clear vision of a more efficient future. This narrative, though fictional in its personal details, encapsulates the spirit of millions of Rosies the Riveter and other workers who, with their dedication and ingenuity, were fundamental to the Allied victory.